the heading change.
Exactly.
Or that is basically the new heading.
Yeah.
So our early the
Initial heading, old heading is how much?
260 degrees.
Yes. And what are you applying here? You're applying the track change, which is equal to heading change, which is equal to 8 degrees left. So left is anti-clockwise, 260 minus 8.
It will give me 252 degrees.
Magnetic. This is a new heading. Now can you tell me some other way of finding new heading without analyzing this track heading changes? Any other way, which we just saw before?
That drift we can.
Exactly. So we can actually find the actual drift here, 5 degrees port. With 5 degrees port and with a track. So what track am I supposed to fly? 255 degrees minus 8. Right? That's going to give me 247 degrees. So this track is actually a track of 247 degrees magnetic. 255 minus 8. Right? Now with 5 degrees of port drift, what should be my heading? It should be 247 plus 5. Right. And that is going to be 252. So you can analyze it using the actual drift also. Right? Therefore the answer to Foxtrot is
252 degrees.
252 degrees magnetic. Perfect. Yes, golf. What alteration of heading? So this is kind of closing up this particular segment. So you can see the kind of navigation you have done here. We have actually tracked towards your destination. Now, as I've told you, this might not be always possible, especially if you have some kind of restricted area here, mountain here, you might not be able to track straight. You possibly have to find out, have to re-intercept the track as quick as possible, and then you leave at 1000 hours and you reach point C at LI at 1012 hours. You take 12 minutes, and you're traveling 36 nautical miles. How long do you think will the aircraft travel as the time ticks to 1024? So you see the first 12 minutes it traveled over 36 nautical miles. We assume the ground speed to be constant anyways. So for 1024 it's another 12 minutes. So how long do you think it's going to travel? Yes, another 36 nautical miles, right? So 36 nautical miles, another 36 nautical miles, it is going to re-intercept the track. The question is asking what alteration of heading should be made to regain track at 1024. So the aircraft has to now regain a track at time 1024, during which it would have traveled another 36 nautical miles, because it's 12 minutes and another 12 minutes, right? Therefore this distance is again 36 nautical miles, right? You are asked to find out what track change is required to now fly, what heading change is required to now fly and intercept the planned track at 1024. So having understood the fact that we are going to re-intercept the track at 1024, after traveling 36 more nautical miles, we can see that you're asked to find the track change. So see, if I don't do anything about it, the aircraft is going to drift off all the way out like this. Now I have to find a track change that will bring me onto this particular track here. Right? And if I can find a track change, that's exactly equal to the heading change. Right? So what's the track change here? This is question number golf. Right? The track change is equal to, you're on track of 255. To find this particular track change, you can see that this particular angle, so much is 5 degrees, and you have another so much of an angle right here. And if you look at this figure, just like we did the previous case, you have these two parallel tracks cut by a transversal, and therefore that angle is nothing but this particular angle here. And it's pretty obvious that this is going to be the closing angle towards the interception. So how do you find the closing angle? That's just like the normal way, closing angle over here at 1024. This is for re-interception. That's equal to, okay, 160 distance off by distance to go into 60. Distance off is 3 nautical miles. Distance to go is 36 nautical miles into 60. Right? That's going to be, let's find out. 5 degrees. and it's 5 degrees right here, and therefore this is also 5 degrees. So the total track change is a 5 degree plus another 5 degree, which is a total of 10 degrees. So track change is equal to the heading change which is asked in the question, and that is equal to 10 degrees towards left. Right, and therefore what is the new heading? To find the new heading, we know the initial heading is equal to 260. That's right here. Magnetic. We apply this track change, which is equal to the heading change, which is equal to 10 degrees left here. Right? So 10 degrees left is an anti-clockwise change, and therefore that goes to the new heading, which is equal to 260 minus 10, which is 250 degrees magnetic. Alright, so you can see here that the aircraft is kind of tracking all the way from here. At 10 hours, it reaches at 10:12. Now it has to turn left onto a heading of 250 right there to actually track and re-intercept this particular track at 1024. Right? So if you want to find out this particular track which we need to follow, it's 255 minus 10, which is a track of 245 degrees. And to fly this track of 245 degrees, the new heading has to be 250. Right. You can also find out this using this actual drift of 5 degrees port. If I need to maintain a track of 245 with 5 degrees of actual drift, port drift, then your heading has to be 250 degrees. You can find it in that way as well. Alright? Is that clear? Alright. That's about golf. Let's see what is the next one. Hotel. What heading should be flown between 1012 and 1024 hours to regain track at 1024? That's exactly what we just found out. The new heading to be flown. So our track alteration is 5 degrees, and then 10 degrees left, and the new heading to be flown is 250 degrees magnetic. Alright, perfect. Now India. Given situation in Gulf and hotel above, what heading change should be made in 1024 hours, and what heading should be flown from 1024 hours onwards? Now see, there's something else which you have to consider here. Now the aircraft starts flying a heading of 260 on a track of 255, and now re-intercepting this particular track at 1024, it has to fly at a heading of 250 on a track of 245. Now if I don't do anything about it, after interception, you can see that I'm now going to drift off exactly in the opposite direction. Now what was initially a track error towards the starboard now becomes track error towards the left or towards the port. So to prevent this from happening, that is, if I don't do anything about it, I'm going to kind of track all the way straight on a track of 245 out. Now I'm drifting exactly the opposite direction, the other direction. Now what they're asking is, basically once you reach here, you are supposed to now make a track change in such a way that the track changes from 245 all the way up to 250. So you fly all the way on a heading of 250. Now once you intercept, you turn right, and now to fly a heading in such a way that you fly a track of 250. So you can see here we are experiencing an actual drift of 5 degrees port. So with 5 degrees of port drift, if you want to maintain a track of 250, it's a port drift, which means track is to the left of the heading, and therefore you have to maintain a heading of 255 degrees. So the heading to be flown along this track of 250 towards the destination is 250. And what is the change in heading required? Change in heading required is nothing but change in track, because track change is equal to heading change. What is the track change required? From a track of 245 to try and turn right by 5 degrees for a track of 255, and to fly that track of 250, and to fly that track of 250 you have to be on a heading of 255 to accommodate for 5 degrees of port drift. So let's see that. So what is asked here in India is basically the track change or that is required. They're asking the heading change that is required at 1024 to kind of track through the planned track towards destination. So you're initially on a track of 245 and you need a track of 250. Therefore, the track change, which is also equal to the heading change, is 250 minus 245. That is 5 degrees to right. Right? And therefore, what is the new heading? New heading is equal to your previous heading of 250 and we apply the track change, which is equal to heading change of 5 degrees right. Right means clockwise, the magnetic heading increases, it becomes plus 5, that is 255 degrees. Magnetic is a new heading to be flown. Or you can find out by applying the actual or experienced drift onto your required track of 250. Perfect? Yes. And the last question here, Juliet. Estimate the ETA at Oxford, right? So we know that we rediscovered the track at 1024. You now start tracking all the way on the planned track up to O. You're asked to find out the ETA here. That's pretty clear that if you have the time 1024, the interception time is 1024. If I can find out this particular distance here, and since I have the ground speed and I assume it is constant throughout 180 knots, I can basically find out the time. So this is 60 nautical miles. If so much is 36, this is going to be 24 nautical miles. And at a speed of 180 knots and 24 nautical miles, let's find the time. Time is equal to speed is equal to distance by time. Therefore, time is equal to distance divided by speed. Distance is equal to 24 nautical miles at a speed of 180 knots. That's going to give me 8 minutes. Right? Interception is at 1024. You track all the way for 8 minutes, and therefore your ETA is going to be 1024 plus 8 minutes, and that is 1032 minutes. Right? If you track along the route, if you track direct from LE all the way to Oxford on a track of 247, and if you try to calculate the ETA, it's again going to be 1032, because ultimately the distance they're going to take is 60 nautical miles, 36 plus 24, and since the angle is very, very small, this distance is relatively equal to this distance, and for a constant ground speed, the time taken is going to be the same. Right? The answer to question number, Juliet, is 1032. I hope this question is clear to you. This is one question which actually takes you to the entire journey in a go. So usually two things which we do in 1 and 60 is, number one is definitely you find your required track to the station, either fly direct, or as you know, sometimes you may not be able to fly direct because you have some kind of restriction here in the form of terrain, in the form of restricted airspace and stuff, or traffic. In that case, you might have to rediscover the track as quickly as possible and get back to your destination. Now, that is one thing which you find out by applying 1 and 60 exactly in the way you found out. And second thing is what we just did here. We kind of revise the ETAs based on the on the ground speed. So that these are two main points, or two main dead reckoning elements that we look into at the 1 and 60 point. But even though theory doesn't much talk about the ETA revision in your syllabus, that's also an integral part of your VFR flying, because the ICAO rule, if you know, it states that you have to be within 2 minutes of plus or minus 2 minutes of your ETA, right? So that's done. That is kind of kept in the range using this ETA revision. All right, perfect. So let's very quickly look through the journey once again. So the aircraft starts from here all the way, tracks all the way on a heading of 260, tracks to 255. You're now asked to read this, track straight to destination on a track of 247 all the way straight up to here. Now, the second case is where you reach or see, you understand that you're off, and you're asked to now readjust the track on 250 or a track of 245, and then you have to now turn right. If not, you'll keep drifting away. Turn right and then track towards the destination. I hope this question is clear. One very good question that can actually take you through the entire process in a go. All right. That's it. So we have kind of done with the application of 1 and 60 as far as in navigation is concerned. Right. The next class we will talk about application of 1 and 60, finding out height on a glide slope, rate of descent, as well as gradient, which is particularly important, especially when we talk about application 1 and 60 in ILS, NDBs, in DMEs, etc. This knowledge will be definitely helpful. All right.